Okay, so how do we find slope? Well, we find slope by using this ratio of the change in y over the change in x. So we have these 2 points here. We have point P, we have point Q, and we have a change in y, which we're going to call dy, okay? And we're going to have a change in x along here, which we're going to call dx, okay? And the dy and dx imply infinitesimally small changes in y and x. So it means that the P and Q points are really, really close together. So we're going to use that slope ratio, and we're going to let the points come together. And this is how we're going to do it. So let's say we're going to find the slope at x equals 2. Okay, so x equals 2 on that parabola. We have the starting coordinate as 2 and 4. So that's our fixed point, and we're going to choose some arbitrary point, 2 plus h, which is just a little bit further away from 2. And so the y-coordinate of that point is going to be f of 2 plus h, which is going to be 2 plus h all squared when we plug it into the equation. Okay, so how do I set up the slope then? Well, the slope is going to look like this. It's going to be the rise, the change in the rise, which is this length here. So that's going to be the y-coordinate is 2 plus h all squared, okay, minus the y-coordinate that is up here, which is 4. So we're going to go minus 4. So that's going to be y1 up here minus y2 down here. And then we want to find the run of this. So I want to do the run. Let's do that different color here. So the run is going to be 2 plus h. It's the right-hand x coordinate minus 2, which is a left-hand x coordinate. So those two coordinates there is going to give me that length in there. So there's my rise and run. Okay, but really if we think about it, the difference between 2 and 2 plus h, when we subtract this anyways, is going to just be h. So we're going to end up with h in the denominator. And what we're going to do essentially is use this limit. We're going to let this limit go to h equals 0. Now when h equals 0, we end up with 2 squared 4 minus 4 divided by 0, which is 0 over 0. But now that we have established the ratio, and we have a limit going to 0, 0, the limit will find out where it's going as long as we can algebraically rearrange it. We can actually figure out what that 0 over 0 is because we know how it's getting there now. So I'm just going to try this out then. I want to work out that limit. So this is a limit as h goes to 0, so I'm going to expand this because I need to algebraically somehow simplify this so I can evaluate that 0 over 0. So when I square this out, I get 4 plus 4h plus h squared minus the original 4. Okay, so that's that 4 there. And conveniently, these 4's cancel out. 2 minus 2 is just going to leave me with h in the denominator. Okay, that's my run. So there's my rise and run. What ends up happening here is nicely these two things cancel out. For plus 4 minus 4 cancel out. And notice what else is happening here. I actually can get rid of the divide by 0 because I have a common factor of h. So that's what I'm going to do. So working that out, I get limit as h goes to 0. And simplifying that, that's going to be 4 plus h squared divided by h is h. Okay, so now I'm at a situation where I can actually evaluate this limit by just plugging in. So when I plug in h is 0, I get 4. So that means that my slope ratio, this rise over run ratio that I started with up here, as we let h go to 0, the slope ratio goes to 4. And it's telling me that this slope of this line, of this tangent line, which I'm going to draw in purple, this tangent line is going to have a slope of 4. And in fact, if you take a look at this, the tangent line on the parabola at x equals 2, y equals 4, it definitely does have a slope of 4. Okay, so we're onto something here because this is now allowing us to calculate this 0 over 0 slope, and it's giving us results that are consistent with what we're seeing on the graphs. So let's try another one here. This is what we want to do. Okay, so let's use the limit here. So I've got a graph y squared, y equals x squared plus 2. So x squared plus 2 is going to be a graph that is a parabola. Okay, it's going to be a parabola that goes through the y-axis at x equals 2, y equals 2, and at x equals 1, we have a coordinate here. That's going to be equal to 3. Okay, so it's going to be a y coordinate of 3, and we have a tangent line at that point. Okay, and we want to know the slope of that tangent line through that coordinate. Okay, so what we're going to do, we're going to arbitrarily find some point h here, or some point that is 1 plus h. So there's my 1 plus h. Okay, and then the y coordinate here is going to be 1 plus h squared plus 2. So I'm going to write it in here. It's going to be 1 plus h squared plus 2. Okay, so that would represent the y position of that graph. Okay, so I have a coordinate at 1, 3, 1 plus h squared plus 2. Okay, so I'm going to set up my slope ratio then. So this is going to be the limit. Okay, so I'm going to use a limit. I'm now going to let h go to 0, so the distance between those 2 points goes to 0. Okay, my slope ratio is going to look like this. Okay, so my two y coordinates, that's the green one up there is one y coordinate, so 1 plus h squared plus 2. Okay, y1 minus y2 is that known coordinate of 1 over 3 up. Okay, and then we get 1 plus h x1 minus x2, which is 1. Okay, but we really don't need to write that because we know that that's just the run, and the run is just going to be the distance between these 2 points, which is always going to end up being h. Okay, so there's my limit ratio. Now I just need to work out that limit. Well, let's just plug in first. So it's going to get 1 squared plus 2 is 3, minus 3 is 0, 1 minus 1 is 0. Okay, so we have 0 over 0. We can't evaluate this limit, but we can do some algebraic simplification here. Okay, so let's do an algebraic rearrangement, see if we can get rid of that divide by 0. Okay, so this divide by 0, divide by h is a problem. So I expand that out. 1 plus 2h plus h squared minus y2, which is 3. Oops, so I forgot the plus 2. This is going to be my plus 2. And then minus y1. So that's y2 minus y1. Well, again, conveniently, what's happening here is that 1 plus 2 cancels with the minus 3. And we have just h terms left, and I really want to get rid of that divide by 0, and those h's allow me to get rid of that divide by 0. Okay, so I'm going to write another line here, limit as h goes to 0. This is going to be 2h plus h squared divided by h. My h's cancel out, so I get the limit as h goes to 0, and that's going to end up being 2h divided by h is 2, plus h squared divided by h is h. I can evaluate this limit. I don't have a divide by 0 anymore. When I plug it in, I get 2. So what this is telling me then is the slope ratio, when the rise over run becomes 0 over 0, it approaches a slope value of 2. And if we look at the graph, that graph line is, the slope is pretty much 2. Well, in fact, it's not pretty much, it is 2 at that tangent point. Okay, so we are able to use this rise and run, y1 minus y2, x1 minus x2, to come up with a slope ratio, and we can let the limit of that go to 0. The distance between those points go to 0, which becomes the tangent point. And as we let it go to 0, we see what's happening to the slope, and we can evaluate that slope using a limit. Okay, and the slopes that we're calculating, the values look very legitimate. In fact, they are legitimate. They are the actual slopes.